Okay, so I had the first agenda item I put on there, which was really to just figure out what our next steps look like, find out from either of you if you have thought about that. Some suggestions I had were just trying to provision an Elasticsearch cluster by picking some tooling available to us. So we'll need to, presumably there's a few options of what we can use to provision an Elasticsearch cluster, whether that might just be some standard scripts for whatever provisioning infrastructure tooling we use, or whether there is some scripts by Elasticsearch that we can use as well. And I think there might also be, Google Cloud may also have something that easily provisions an Elasticsearch cluster for you as well, now that I think about it. But
right, so my intention, and I think Cindy's as well, is to set this up using Chef and Terraform, and we're leaning towards most of our fleet currently is using I guess what I'm really working up to saying is we're probably going to be using a newer release of Ubuntu than any of the other production nodes in the fleet. And so there's going to be a little bit of additional work to work out the kinks in that. There's another SRE team, Dave's SRE team, that's planning on beginning sometime this quarter to do some work to migrate existing VMs. But that work obviously hasn't planned or started yet, so we're not going to get a lot of benefit from that, since I guess we'll be a little bit ahead of the curve on that. So we may get some help from them if we run into a snag, or we may end up helping them out by uncovering snags. I know that we already dealt with one gotcha that was fixed a few weeks ago. Hendrik and I got to work together on that a bit. But yeah, essentially, we'll run it on Ubuntu 2004 VMs, and there is a Chef cookbook for managing Elasticsearch, but I haven't had time to look into that yet. I imagine that we'll prefer to use the community one rather than roll our own, but we'll see if there's a particular reason not to. Go ahead.
Nice. Okay, I did. Yeah, I hadn't looked at it. I just assumed we were gonna use Chef, but yeah, we usually like make our own. It's like GitLab dash something.
Right. Yeah, I haven't looked at it yet, so I don't know if it's going to be necessary for us to do that. But yeah, I think.
So you're talking about the Elasticsearch Chef cookbook? Is that what? Yeah. So yeah, they have one in Elastic on GitHub. So I'll just link that here.
You don't have to document all this. This is. I mean, you can if you want. I'm not discouraging you. Just this is what Cindy and I had kind of informally talked about before the break, and then we were each on call and then on holiday. So we haven't done anything since since then.
Yeah, and, I wasn't documenting it. To be honest,
yeah. To be honest, I think both of us have some follow-ups from those on calls, and I know I got. Yesterday, I got an additional kind of short-term priority to work on. So I'm not promising that there's going to be meaningful progress this week, but I'm hopeful that there will.
Okay. Yeah, I guess that's kind of something then I can talk to other managers about, figuring out how we make meaningful progress on this if you both are perpetually on urgent, but on call, and then follow up work from on call. Yeah.
Right. So the expectation, as Anthony put it to me, was that we've got several months to complete this project, and I don't think that any of us were expecting to have 100% time to dedicate to this project, but.
Sure, that makes sense.
I'm hoping, I'm hoping that this will be our primary focus, apart from other duties. Like we know that we have a couple of open recs to fill, and Cindy and I are going to be involved in sorry, we're adding some seats to the SRE team, and Cindy and I are going to be involved in that process. As well as several other folks. And the on-call shifts are kind of a perpetual burden, as I'm sure you're aware. yeah, I don't know. I don't know what more to say about that.
Yeah, no, I mean, I slightly related topic then, like,
Yeah.
are we having meetings too frequently to the point where we can discuss things much quicker than we can actually do anything? It would be one concern I might have. Like if practically we can't execute for the next 2 weeks, then do we need to have several more meetings in the next 2 weeks? I don't know.
We can cut down to 1 meeting a week. I think that's reasonable.
Me too.
We don't have to have the Thursday one this week.
Okay. I will delete that right now. And I'm actually, I mean, for the second half of January, I'm away. So, you two may end up making, if you have time, making some progress in that time. And then when I come back, if there's sort of questions you have for me, then maybe that'll actually work out better.
Okay. That's really good to know. Yeah, so that's it as far as the first point. I think that's about as far as I had gotten. I know that Cindy and I both have kind of this ongoing desire to do more background learning, which obviously we haven't had much time to do, thanks to the points we talked about a moment ago.
Yeah, the break kind of caught up with us too, like along with on-call.
Yeah, definitely. I think last time we chatted, the three of us together, we talked a bit about garbage collection pauses in the JVM. I did have time to do a little bit more background reading. So I think I mentioned that I have a lot of experience with running PAR-new for young gen GC and CMS for old gen GC, and the existing Elasticsearch and the Java community as a whole is moving towards G1 GC, so I did some additional background reading, looking through the documentation, the Java documentation, and it looks like a lot of the behaviors. I have used G1 GC only a little bit in production, and it looks, and this will, but we should definitely, I think we should definitely proceed with that. That is what we're running currently in the Elastic Cloud instance that we looked at together. A lot of the behaviors that I talked about last time for PAR-new and CMS apply to G1 GC. It has a couple of additional behavior. I'm only talking about this as kind of an update, and I was about to go into a deep dive, and I should just stop. The short version is G1 GC has reached a maturity such that it's the default in the latest version of Java for workloads like ours. I shouldn't say default. I mean it's the de facto GC choice for workloads of our type, and all of the behaviors that we talked about with PAR-new and CMS are incorporated into G1 GC, and it has a couple of additional features that make it more ergonomic and specifically avoid a particular pitfall that really wasn't addressed adequately in any of the other GCs. Specifically, it's a compacting garbage collector. It can run in a mode that coalesces free space chunks, so you don't end up with long-lived JVMs having a lot of tiny bits of unusable tiny pockets of free space. That's been a long time in the works, and it looks like it's reached maturity with G1. So that's very relevant to workloads like Elasticsearch, where we expect a variety of object sizes to coexist in a very long-lived heap. Yeah. Okay, I'll stop yammering about that.
Okay, but you also mentioned that you'd confirmed that's what we're already using, right?
Yes.
Okay, and so then we'll just continue using that. Okay. Yeah, I mean,
there are a handful of tuning aspects that we'll address once we settle on sizing. I think we talked about this before, but I'm going to, for now, assume that we're going to work with about a 30 gig heap per node. There are benefits to keeping the heap size under 32 gigs, at or below 32 gigs, and I don't see any reason to avoid that. I think it would be beneficial to have more nodes rather than an excessively large heap. All of this obviously subject to observational data, which we'll be able to collect once we get a working cluster. The Elasticsearch tarball comes with its own JDK. In previous work, we didn't use that JDK. We used a separately installed JDK. I don't see any need to do that in our environment. So unless something comes up, I'm going to lean towards using what they've packaged, because it's obviously guaranteed to be the version that they've tested. And we don't. It's not like we run other Java apps that also require a slightly different JDK. So I want to make sure that we have access to all of the relevant tooling. So like we'll iteratively deal with implementation details like whether we want to expose a JM export, how we want to expose it, what we want to how we want to collect metrics and things like that. But just to get off the ground, I think our first bit's going to be just getting the base chef recipes working on the Ubuntu 2004 and figuring out how we want to integrate with the Elasticsearch metrics with Prometheus. I think should be an early target as well. Once we get a trivial cluster working. All right, I'm going to stop blathering now. This is just like stuff I wanted to chat with you all about, but I should have just written it down, I guess, in the agenda.
No, it's all right. So
yeah,
getting the cluster up and running and then testing it with Prometheus metrics is what you said is there.
Yeah.
And we'll be having some Prometheus export running on those nodes to make those metrics available.
That's my assumption, but I haven't looked into it yet. I mostly want to kind of not so much select what metrics we want to collect, but choose the mechanisms for metrics collection as kind of an early thing, just because like with any project like this, I want to tackle the areas that are the largest unknowns as early as possible, and that's a yeah. you see where I'm going.
Yeah, no, it makes sense, and I mean, like I said, we don't want to go to a point where we have less metrics than we have today. But also using the Elastic Cloud monitoring we have today has a lot of flaws because, we get all of the graphs that they give us, but, no ability to customize or aggregate differently, etc. If we need to, like something that just came up today was like every index appears on a separate page for all the graphs and every node appears on a separate page for all the graphs. But if you need aggregated view to see like 10 nodes at one time to kind of get a sense, I want to see if any individual node was playing up. You have to open 10 tabs and then try to go through them one at a time, and that becomes overly cumbersome. So those kinds of things I assume would be much easier for us to do if we just had the data in Prometheus and we could just pivot it however we liked.
Yes, I assume so as well. Hopefully we're right.
Okay, I just thought I'd just bring up, since we were talking about garbage collection last time in the context of trying to re-index something, what happened, we did notice garbage collection pauses that possibly led to the re-indexing failing. That I just linked the re-indexing issue there that we were working on that was the change request, and I was trying to find, but I haven't found yet, the issue I've created to actually just implement our own re-indexing strategy. So re-indexing is something that we're almost certainly going to have to do again in the next 6 months. It's just a regular kind of maintenance task you have to do with any Elasticsearch index whenever you change anything. The re-indexing that's built into Elasticsearch, as far as I can tell, is just simply unreliable, and we just cannot use it. If a garbage collection takes too long, or if a node disconnects and reconnects, it's a process that takes 16 hours to re-index, but if any single failure occurs on any process during that time, it won't retry. And that's just like not acceptable for any task that takes longer than a minute, really, because the failure rate will be 100% at 16 hours. So
that makes sense. So if this is a common activity for at least for long-lived index, so my experience with Elasticsearch is generally for short-lived indexes that that expire and get dropped after, for time series data is what I'm saying.
Yeah.
So this is my first time working with Elasticsearch with indexes that are meant to contain data that lives approximately forever. It sounds like this is a generic problem. Is there not like a community solution for it? Having to rebuild the indexes?
At least I've seen Logstash is somewhat popular. So you can write these Logstash pipelines that search and index elsewhere. So that is another solution. We can run a Logstash pipeline on just any server somewhere. You tell it to execute a Logstash pipeline, read here, right there.
Yes.
But you will want to do that concurrently. So maybe on more than one node. And I mean, so yes, we could certainly orchestrate something with a Logstash pipeline. In my head, it doesn't seem easier than the solution I'm imagining, which is make use of Elasticsearch's inbuilt reindexing, but orchestrate it externally with GitLab with retries in places. So I have an issue there where I broke down the task, but basically we just kind of we tell Elasticsearch to run 100 reindexes concurrently, which are just small portions of the index. And if any one of them fails, we just retry just that small portion of it. So we can still make use of the Elasticsearch's inbuilt reindex functionality, but we implement the retries externally in some kind of orchestration from GitLab. The Logstash option would be very hard for our self-managed customers to use because it needs to be orchestrated on some server. I don't know, shelling out to Logstash from Sidekick doesn't seem ideal to me. And running and expanding GitLab's infrastructure even further so that there's separate nodes that have this responsibility in GitLab generally is also not ideal, because obviously that requires changes to Omnibus and every other way of running GitLab. So pushing the work over to Elasticsearch servers, of which there is only the reindexing task that Elasticsearch supports. That's the only functionality we can do for that. That seems like the only viable option I can think of in my head. But yeah, obviously the possibilities are endless if we're okay with just running such and such a script from the community here. But if we want to build it into the product and make it something that's a bit more hands off, that's not exactly ideal.
Yeah, that makes sense. I'm really just kind of, tentatively exploring the solution space. Yeah, that makes sense for the bits that I am aware of so far. I don't think I'm definitely not up to date on the issue that you've linked.
Yeah, I was trying to find that. I mean, last we were working on figuring out what went wrong with the reindexing, and I attempted it many times, back and forth with support. Every time it failed during the window for some various different reason, and none of those reasons seemed consistent. I think the latest reason it failed, actually, we determined that there was a new back pressure feature implemented in Elasticsearch, and that back pressure on indexing just caused one of the indexing processes to fail, which caused the entire reindex to fail. So like back pressure, which is good, is coming from the receiving end of the index request, which then caused the indexer to go, oh, well, I guess I have to give up now, and just crashes everything. So
back pressure is fantastic, except when you don't have retry logic.
Right, yeah. So exactly. So, what we just learned was 3 times it failed, all 3 probably different reasons. And as a consequence, we just can't use that without implementing our own retry orchestration on top of it, which we did very manually. I just hacked together Ruby scripts that would basically find and retry the small failed subtasks. And that was how we eventually got it done, but it took a long time.
I see. That makes sense. Do you know, just for reference, since you were working with support on this, is support gonna give this as feedback to the Elasticsearch development community to?
Yeah, I've had an open issue with the Elastic on the Elastic project. That's I mentioned in the support ticket, and they said they're going to follow up on that as well. And there is open Elasticsearch issues to improve the reliability of the reindex tasks. Some of which of the ideas I proposed are part of that plan. Seemingly some of it they've got a slightly different direction they're going to go in. But either way, since I've been following that for at least 6 months, they haven't really made any progress on that. So again, I'm not necessarily holding out for them to just fix it on their end, basically.
Yeah, that makes sense. Yeah, I just since this sounds like a generic problem, I wanted to make sure that they were going to take some action for future people that run into this.
My assumption is there's like internal reasons on Elasticsearch side why what I'm describing is actually incredibly hard to do over there.
Okay.
Yeah, so that's my guess, and I've proven that it's easier to do outside of Elasticsearch with the scripts we've written to do it. So at this point, just building them into automating it into GitLab is probably our only next option.
Okay, that makes sense to me.
Then I was just found the issue, so I could actually link that to finish off that discussion there. And okay, so the other thing that is pretty relevant for our team at the moment is that the performance of our searches just gets consistently worse over time and has been for the last 2 months. And I've been working with support. The support ticket's linked on there, and both of you can view that as well, but I've not really made any progress on figuring out why with support. Sort out of leads onto where to look as well. So I'd really happily have any input from anybody on this topic, really. But
how can you give a sense of how pressing this topic is? Like, should we take time away from the migration to try to tackle it?
Yeah, I mean, if we have strategies we can look into, then yes, definitely, it's pretty important. I mean, like you both know that the Elastic stuff. We haven't had up until now a ton of support from SREs, and there's probably areas that of kind of the SRE skill set where I just kind of don't have the right knowledge in order to know where to look or know what to next try here. So I would absolutely like any ideas about what we can try next. If we're really out of ideas, the only options I had left were like, we are already making major architectural changes to our index that we know will massively improve performance. So that work is ongoing from a development perspective. So that is one thing that I can help with, and that our team is already working on. And the other one is migrating to self-managed, which will potentially give us the visibility boost that will help us fix this problem. So, those are the only two remaining things that I know we can practically work on to help the problem right now. So we are, but if there is another option, which is actually we do have more visibility into Elasticsearch now than we did 6 months ago, because we enabled logging, because we enabled slow logs. There are more tools available to us, and so if you two have time and also have some potentially if you have some working day overlap with some other experts on Elasticsearch in your SRE team, then making progress and taking a look through that issue and seeing if there's any other areas you can that we can make progress on, that would be good. The issue is pressing in the sense that searches just keep getting slower. I mean, I don't know if there's a point at which this thing just becomes completely unusable, but since I've been tracking it for the last 2-3 months, searches on average have become 6.5 times slower, and memory usage across a bunch of different things seems to be growing in ways that I don't fully understand. One thing I noticed only just recently is there's like cache memory that's growing. So Cindy, you asked about caching, and caching settings should all be the default. We haven't played with them, which means I believe that there is both. What did you ask about? Node caching and shard caching, I believe, would be both things that are enabled by default to some extent. And I noticed recently that our cached memory usage of the nodes was growing over time, which seemed kind of strange. One of the things I also noticed in my most recent testing is that search, if I just pick a single search that's slow, every time I retry it, it gets slower and slower every time I retry it. So it almost made me think like caching is making things worse. Like it's putting something in the cache and then it's searching a very large cache to find a cache hit, gets a cache miss, and then does the search anyway. And then the cache gets larger where the cache is something else wrong. And I don't know, something along those lines might lead to worsening performance. Alternatively, me just refreshing the page 5 times in a row may be enough to just make the cluster slow. That might also be the explanation, but that would have to be under the assumption that our usage was so low that me refreshing the page 5 times in a row in the space of about 2 minutes was actually enough load to slow things down, which would surprise me.
Yeah, I love looking into performance problems like this. But
good, we got a
I also know that I would need to. But I also know that I would need to take a day to come up to speed on the work done so far and the nature of the problem. And I kind of suspect, like just from your description, I can imagine 2 or 3 behaviors that might be relevant or might be just background noise. And I don't know if we have the ability to observe the JVMs and the node. Like if we were running our own cluster, I would definitely look at. I have some specific steps I would like to take, but I know I'm certain that without shell access, we won't have access to run that level of tracing.
Okay.
Which we will be able to do when we are running our own cluster, which is part of why I'm like, should we defer this investigation until we're running our own cluster so we can directly observe this behavior? Does that sort of make sense?
Yeah, I agree with you, Matt. I was looking at the metrics we currently have, and I was pretty disappointed that we don't have more. And maybe we would get a benefit if we run our own and set up more observability, because we don't really, from reading the issue, it doesn't seem clear to me where it's slow. So we would have to determine where that is, and we can't really do that. And machines we can't really SSH into.
Yeah, I'm with you. I don't like. Do we have? We do have. Let's see. Yeah, it's like I have some half-baked ideas about how we would set up an experimental rig to be able to directly observe the behavior on one or more nodes that participate in serving the query, but or possibly doing distributed tracing to try to identify the dominant code paths.
And slightly related to that, there is an Elasticsearch profile API, of which I've kind of added some screenshots and profile snippets there to the issue. So if you search on that page for profile, that breaks down where it spends time on a query. But when I look at it, it says it spends all its time on calculating the weight of a document, which means to say that when you do a search, every document it finds, it needs to figure out what are the most relevant documents to serve up based on your search. And the most relevant ones are the ones where the search word you use is in the title of the issue, for example, or the search words that you search for are used multiple times. So that's much like Google search. That's how it kind of determines what are the relevant documents to serve up and then sorts those results based on that. It seems to spend most of its time doing that task. Now, it doesn't really help me because I go, okay, well, I can't not sort the results. So, that I'm using the kind of a bunch of just sort of pretty standard Elasticsearch queries. So, and in my head, kind of, I think conceptually sorting the results probably is one of the more expensive tasks to do when you have many documents to search across. But yeah, that's kind of where that is.
Yeah, that makes sense. I mean, I think it kind of seems like the you would expect over time the size of the search space to grow and potentially the size of data sets that need to be sorted would grow. That implicitly means traversing more chunks of more shards. Along with that effect, you would expect, I forget what Elasticsearch calls their compaction process, but it's kind of like Level DB's strategy for
merging segments.
Merging, yes, thanks. yeah, you would expect that to have an effect in terms of like just like file system level caching of the block device blocks of the file system that contain the relevant pieces of those what am I trying to say? This is where not being up to speed on Elasticsearch's vocabulary is kind of hurting my ability to describe the problem. So there are going to be chunks of the indexes shards that are represented on disk in data files, and I can't recall what Elasticsearch calls those.
Segments.
Segments. Thank you. So yes, effectively, I think we'll have to visit more segments or more pieces of more segments, just as a result of the number of documents growing that could potentially match the search results. I'm kind of winging it here because I haven't looked at what query is.
Yeah, I think what you're saying is, in general, if the index grows in size, then things become slower over time. It's kind of unavoidable, and I think that's true. And I'm
but a 6x increase is that's it, right? that seems kind of a disproportionately large growth over the course of a few months.
Yeah, and one of the things I observed, but maybe not necessarily maybe I wasn't very disciplined about being 100% sure of this observation, is that we doubled the number of nodes in our cluster while doing some other administrative task recently. And I think that did not improve performance. So that's one thing to factor in here. And it's probably an experiment we should run in a slightly more disciplined way, but like if Elasticsearch is meant to be horizontally scalable. If it gets slower over time and you need more resources, then you add more resources, and that should make it faster. But I have a suspicion that based on the fact that none of our nodes seem overutilized based on any of the saturation metrics I can see, that even if we double the number of nodes, we're not going to improve performance for anything. And I think that's kind of in line with what I saw, though we can actually try that experiment again as well. That's like another possibility to look into. If we've got to pay more to run a cluster the size we're running it, then we have to pay more. That's probably just one factor to think of.
Yeah, I agree that we should do a carefully controlled experiment where we add nodes, because that results, if that result is reproducible, if we believe that result is correct, that adding nodes did not improve the response time for this query, and that the workloads before versus after were comparable, that cuts out a large portion of the candidate explanations.
Yeah, another data point to that effect is also that I find that searches aren't faster on weekends based on the data that I have. The aggregate search performance is not faster on weekends. It wasn't faster during periods of time where search volume was considerably lower. So that was kind of another data point I have to the thinking that it's not just growth that's causing problems. There's something else about individual searches being incredibly slow.
Yeah. So there's this generic pattern that I first encountered many years ago in the context of disk storage, but it's much more general than that. And the pattern in the context of disk storage is called serial I/O. A lot of times you talk about sequential I/O and scattered or random I/O as being the two broad classes of I/O on a block device. But taking it up one level of abstraction, there's this concept of serial I/O where, which comes up really often in like index-based database queries, where as a good concrete example, and the pattern is this: the application, whatever it may be, whether it's Postgres or MySQL or perhaps Elasticsearch, the application logic has to complete one I/O and do some potentially trivial computation before it can compute what the next I/O should be. So a concrete example of that is you want to look up a row in table foo using an index, and so you need to go look up the index block, fetch the index block from disk, perform that minor computation on the index block, i.e. traverse that index node, before you can find out what is the actual block ID of the block in the table that contains the relevant row that you're asking for. So that's the kind of the generic pattern for sequential IO. In that pattern, when sequential IO is the dominant bottleneck, you won't see disk being saturated, you won't see CPU being saturated, you won't see any particular machine resource being saturated, because the bottleneck is this logical IO pattern. That sounds very much like what you're observing here, where there is no single physical resource that increases, that reaches or even approaches a saturation point, and adding nodes didn't seem to. I guess the fact that we added nodes and the fact that you don't see improvement on the non-peak time of day and week suggests that it is endemic to that particular search, rather than competition for resources. So that also kind of matches the kind of, I guess what I'm trying to say is serialized tasks. I'm trying to come up with a phrase other than just saying serial IO.
Yeah. So no. What you're saying makes a lot of sense to me. It seems quite logical that if you single thread some task that needs to be done,
yes.
it doesn't. You're never going to hit the saturation point of things that can handle large concurrent workloads.
Yes, because it vacillates between IO and compute, and
yeah.
if you can't splay that, if you can't parallelize that work. I guess this is where kind of the concurrency model comes into question for me. When looking for a document, I'm sure that there are some things that can be run concurrently, and other things that probably can't be run concurrently.
Yeah, I mean, my understanding is quite a lot of it should be concurrent. I mean, well, we have like 10 nodes that will be serving up the search requests. Each one of those goes off and concurrently finds all the documents. You do have something coordinating that then merges those documents to find the highest rank ones, and maybe that ends up being a bottleneck. I don't know, but that is not really IO based either. That one's kind of just like aggregating data from a bunch of other servers. But
and I would assume that within any given node, you might potentially farm out several worker threads to concurrently work on portions of that task as well.
I believe you get one thread per shard that is being searched. So yes, each node would probably be concurrently running against all of the shards being searched. In the case we're talking about group scope searches. So basically in GitLab, you search for issues within a group. That's the specific case we're seeing is really quite slow. And since a group the GitLab org group contains thousands of projects, all of those projects are sharded based on a project ID. But once you hit more than I think like 20 projects IDs in our application, we just go, okay, well that's all shards then. We can't just isolate the shards that are relevant anymore, because you've got too many shards. We're just going to search everything. So we don't do shard scoped searches under those conditions. So it'll be hitting every shard of every node, which will be doing concurrent things across everything, I guess. But yes, those are the ones that are specifically slow.
Okay, that makes sense. So again, I guess I would. Oh, go ahead.
I was just going to say the specific detail you give makes sense, and what I think the only thing that kind of comes to mind is you have like the option of like figuring out a logical way to parallelize things, like you described. But the other thing is you have the opportunity to run faster CPUs and faster disks is your other tool you would have available there, right? You obviously can't run more CPUs, that won't fix the problem, and you can't. Disk caching is probably a relevant factor here too. Maybe giving the operating system more cache memory might also help with this problem in theory, if those same disk IO patterns are happening regularly.
Right. Exactly. This is a big part of why I'd like to sizing the file system cache for the node for when we build our own cluster. That's one of the biggest open questions in my mind about what we want to provision, and it's not a question that we have to get exactly right up front. Like we can be wrong, we can afford to be wrong and change the sizing. I think that would be pretty straightforward, especially if we do so before we go live. But even post production, it would be acceptable to take one node at a time offline to grow the memory but not grow the JVM's heap. But yeah, like understanding a problem like the performance problem that you're describing here. I think anytime we have like a chronic growth in response time for what we kind of logically conceive to be a static query, I want to know what resource it's spending most of its time. What action is it spending most of its time doing, and what resources does it use to support those tasks? Like sometimes there's a logical resource that we can adjust, sometimes it's as simple as tweaking a setting that limits how many concurrent threads per JVM are allowed to work on any single task. Sometimes it's like adjusting the number, the number of semaphores available to do work. And sometimes it's just it's not possible to improve. So this is where, like, exploring a problem like this would, I think, be educational for at least for me, in learning more about the constraints, what options we have for tuning a problem. But of course, first we define what the critical path is in the Elasticsearch code, and what tunables do we have at our disposal for adjusting it. Yeah, like I guess at the end of the day, it really comes down to the basic question of where is the time spent, and I kind of feel like we don't have enough visibility at the node level to answer that question reliably in the Elastic Cloud environment. At least from what I've seen, I don't think we have enough visibility into that.
Yeah, I'll give like a brief kind of summary of what visibility we have here. Oh, not that one. This one. Okay, so so what I am doing here to test a slow search is, if you go to the GitLab org group in org group here in GitLab, slow search, just search anything here, it doesn't matter. Click slow search, hit enter, and unsurprisingly that takes a while. I should have searched for fast
You're
search.
searching for this slow search.
Anyway, then click on the issues tab. So the projects is not really all that interesting because there's a much smaller corpus of documents to search in the projects there, though surprisingly still takes ages. This is like, at the moment, this is even slower than it was yesterday, me just doing this search right now. I'm not really sure why.
So the clock starts when you click to the issues tab, is that right?
Yeah. So what up here, you may both be familiar with the performance bar. If you hit PB, you'll see this on any page. This is what you're interested in, this ES time. So we get one query to Elasticsearch. It took 10 seconds to get those issues back. And what I was observing is if I click search on this again, okay, I got 2 seconds that time. Maybe this is not going to have that same characteristic behavior as yesterday. Though the specific example of the search that I was seeing slower and slower over time was actually, that just went to 8 seconds, whatever. Anyway, the example I gave here is actually one that searches for much more words than that. And the more terms that are in there, so that's 2.2 seconds. Anyway, this, if you're look up here, this is exactly the query that happens to Elasticsearch. So from that perspective, we can then go, okay, Elasticsearch should be able to profile this query, which, this is, to expand that whole thing, this is the actual Elasticsearch query. Basically, it says, find me any documents with this project ID, of which there's thousands in the GitLab org group. And that matches, very simple, it matches this query here. So standard Elasticsearch query, run the profile on it. I get back this. I don't think I uploaded the actual profile on here because I uploaded it on the Elastic support ticket, but I didn't upload it on here because this is public and I wasn't sure what was in it. But they have a profile API you can call. The profile, if you look at the profile through the Kibana UI, so our Elasticsearch production server has a Kibana UI, you can go to it, go to the search profile. Much easier to view the profiles in that than it is to look at the JSON output of the profile API. So when I say Elasticsearch profile API, you give it a query and it returns you the profile information about how it got the results, much like Postgres would. Bunch of stuff in here, mostly mentioning that it's spending its time checking if the description of the issue contains the word search, if the description of the issue contains the word why, or the title of the issue contains the word why. These are all the different timing issues for the subtasks that it needs to do in order to get this work done. Where if you click on and expand further into those things, it actually gives you a further breakdown of, for example, here I've clicked on description why here, so this was the longest time it took in this one, and over here it tells you what it did in order to figure out if the description of a document contained the term why, and the majority of the time spent on create wait, 93% of the time create wait. That's kind of roughly what I have learned about that so far. It does give you a breakdown of what's going on. This profile information, I believe, comes from Lucene underlying Elasticsearch, and I have a suspicion that Elasticsearch itself is not doing enough profiling internally to tell you for sure whether or not there's something kind of inside Elasticsearch that's actually taking quite a long time as well. If it just profiles the work that Lucene's doing, that is to say, then it may not actually be profiling a bottleneck that's in Elasticsearch itself.
So in the case when when you collect these profiles, this looks like this, just judging from the format of the output, this looks very much like JVM based profiling. So it should be accounting for, so that self time versus total time. I would interpret that to mean to represent wall clock time, regardless of thread state.
I don't know about that, but maybe. Whether
so this is an API
JVM,
endpoint.
yeah, it's an API endpoint. I don't know whether or not it's delegating to JVM timing, but maybe. Mm-hmm. This is the documentation.
You can get something similar with JConsole attached to a JMX port dynamically.
Okay. So the profile details provided by the profile are directly exposed.
I'm only mentioning this because I'm interpreting the results as though it's collected in that way.
Okay. Yeah, and you might be right.
Because I'm not familiar with this profiling API. Okay.
You might be right in terms of that's what it's literally doing. It mentions Lucene class names, so maybe it's just, when it calls out to Lucene, also asking it to profile that using JVM profiling.
Yeah. So the bit you've highlighted here, where it's spending 93% of its time in the create wait. I'm guessing that create wait in this context is a method that's involved in scoring the I see that it's caller. So if I'm reading this right, then build scorer is the caller for create wait, and this is a weighting scheme for generating a rank for the search result that it's processing.
Yeah, I'm not as confident as you that this is some kind of call stack, some kind of like flame graph call stack sort of depiction of this. I don't necessarily get that reading from this.
That side panel, I'm not sure how to interpret. Yeah, the side panel where your mouse is now, I'm not sure how to interpret that. There was another representation you'd shown earlier that was more familiar to me.
Well, that was only that one. This one, yeah, that's exactly what we're looking at here. But that one is what we're looking at here. There's one without the expanded side panel, which is just this.
Yes, that's the one. That's the one I was thinking of.
Yeah, so this is just the same thing, but if you click view details on the right side, that was what the side panel is. But yeah,
okay.
Yeah, in this case, this is broken down by server, by node and shard number, and then all of the steps all of the work that it does on each node and shard.
Yeah. So at least the way it's drawn here, this looks a lot like how JConsole will. This looks like the way that JConsole will present stack profiling.
Okay.
Where it will sample the stack of every thread at a periodic interval and aggregate them together and represent them. Yeah, this was before flame graphs were a hot topic, but this is another way to represent an aggregation of many stack traces across potentially across threads.
Okay.
Yeah, so that's what I was guessing we're looking at here, and I don't know about. I'm assuming that the side panel. I was guessing that the side panel is representing the same thing for a single call path. Like, but again, I'm not familiar with this interface, so
there's
maybe
another tab that says aggregation profile. Is that the same thing, or
no? The aggregation profile you can ignore because it won't have anything on it. Because if you do an Elasticsearch query, your query can either compose a search, like where you're searching for documents, and you often want to also include an aggregation in there as well. So like, for example, I want you to find me all issues that match these words, but I also want you to return me an aggregation across those same issue documents where it says how many of those issues contain this word versus this word, so that you can build out some kind of dynamic faceting tool. So like imagine you're searching for cars and you say, I want to find all Fords. And then you might also, in the same query, you might issue an aggregation to request the year number of the Ford car. And so then, a common query that you might issue would then give you back a separate aggregation data saying all of the Fords that were 2020 models, 2019 models, etc., come back in the same query, as well as the actual first 20 Fords that you searched for. So anyway, our searches don't include aggregation queries, so they don't have an aggregation profile associated with them.
Okay, this would be like a SQL query having not having a group by versus having a group by.
Yeah, but in Elasticsearch you issue them both at the same time.
Yeah, that makes sense. Find the matching documents and then optionally do something with them.
Yeah.
Okay, fantastic. Yes, so like taking it up a level of abstraction. So I can't tell from that bit of profiling how many threads were involved in doing the work. I wonder if there's some other way we can kind of infer that. It may just be that you have to know the behavior. I'm mainly thinking like I don't know enough about Elasticsearch's thread pooling model. It doesn't make sense for it to allow an arbitrarily large number of threads to do work, because there's this discrete overhead with managing those threads and the thread pools. So like if I'm making this up, I'm not saying this is what happened. This is what's actually happening, but I'm trying to think of a way that we could, without having the ability to directly inspect the JVM's behavior, I'm wondering if there's a way we could kind of identify with how earlier you were showing us that you had really erratic response times. They were all bad, but when you reran that query, sometimes it was 10 seconds, 8 seconds, 2 seconds, and it wasn't like it was monotonically increasing or decreasing. It oscillated from one request to the other.
Yeah, well, interestingly, on two separate occasions, I've seen it consistently just go, oh, actually, no, this went up and then down. Actually, I take that back. Okay, that didn't go up, but then, yeah, okay, this day. So probably it's just erratically getting larger and maybe jumping around a bit.
So that made me wonder if, like, for example, this is the part where I'm just totally making it up. If there is a fixed size thread pool and there are other competitors. Okay. And if there are other competitors for the threads in that pool, again, totally making this up. Suppose there's a thread pool that's shared between ingesting new documents versus serving queries, and we get a batch of new documents to index, and they start consuming 60% of the thread pool, and then 500 milliseconds later they finish that task. If we're unlucky enough to submit the query while that thread pool is being competed for with the ingestion work, then we'd naturally lose some time to that, and I'm not sure that would show up as a difference in the profile, with or without competition. Does that sort of make sense?
I think I understand what you're saying. If you end up queuing for threads in order to perform a search, then maybe that queuing time is not accounted for in the overall profiling, and therefore, the profiling may not tell you anything meaningful about that queuing time.
Yes,
possibly.
Exactly.
I
And it's
imagine
also possible that if
almost
there's
certainly that queuing is not covered in that profile API, which is pretty naive. It's actually saying specifically it's delegating to Lucene, which would be much further down the stack, much lower than Elasticsearch's internal queuing mechanism before it even delegates to anything to Lucene. So I would guess so.
Okay.
Indexing, one thing you mentioned, indexing threads and search threads. I believe they're two separate thread pools. There should be, because
That
I've
totally
seen.
makes sense. I guess
Yes.
a more plausible example would be other competing queries that would
Yeah.
want to borrow from the same thread pool.
Yeah, so if I look at the individual nodes metrics here, we have we do have a search queue, so we can see queuing. I believe this is potentially relevant to what we're talking about. Rejections, no, there's no rejections happening, I guess, but so number of search operations in the queue, shard level searches.
So I wonder if that means like, okay, shard level search. Okay, so you know how you mentioned earlier that that this particular search example is not going to be constrained to only run on specific shards, that it'll hit all shards.
Yep. Yeah, well, it'll hit all shards
right?
of all nodes. Yeah, so
Yes.
but I'm only looking at a single node right now, but yeah.
Yes. Okay. So so on I guess I'm not quite clear on how the work is dispatched. Like, would the representation of time spent in the queue, would that be at the level of inspecting, like a query comes in through the API, and that query gets decomposed into smaller units of work that are going to operate on individual shards. And I'm not sure if the queue time that we're talking about is for the query as a whole, or if it's those smaller units of work having to wait. Like this is me not knowing enough about the processing model.
I don't know the answer to your question.
Sense?
All only thing, the hint that I get is like number of search operations in the queue, e.g. shard level searches. I don't know. I'm kind of imagining each node would have its own search thread pool. Now a node will obviously have a certain number of shards on it. I wouldn't think that each shard would have its own thread pool, but I might be wrong.
This is making me really kind of want to okay, this might seem a little bit silly. Tell me what you think. I'm kind of wanting to maybe defer work on this until we've built our own local Elasticsearch cluster, and then snag the data from production and see if we can reproduce it on our own cluster. Because questions like this about how many threads in the thread pool are actively working concurrently, we can observe that in real time if we can connect to the JMX port.
Yep. Yeah, so
that'll let us answer a different class of questions. Does that make sense?
It does. And if it turns out that we can reproduce it with just a single search, and we don't have to even worry about all the extra load of all the other things that would happen in production, then that would be great. If it turns out we can't, then we won't have anywhere to go with that, because we just need to cut production workload over to the new cluster before we can actually see it. But all that being said, it's not necessarily a particularly expensive exercise to try, especially if we're already trying to figure out how to provision a cluster, etc. We just provision one, restore it from a snapshot of the production data, and see what we can learn. I had tried to do this in the past. My only concern was how much that was going to cost me on Elastic Cloud. And I thought, look, if I've got to spin this thing up, it's going to be costing me like $1,000 a day. And if I don't have a clear plan and I'm just trying things out, I'm going to feel like this might be a very wasteful exercise. But if we can figure out running it on our own infrastructure is not nearly as costly, then I'd feel much more comfortable with that. So keep it running for 2 weeks and just try a bunch of different things out without worrying that it's going to cost way too much money.
Yeah. Plus we'll have new angles to observe.
Yeah, exactly. We'll be able to get more data than we would have in Elastic Cloud as well. Yeah.
but you're totally right to call out that there's a meaningful chance that we won't be able to reproduce the problem because it will be very different infrastructure with with different resource, different background workload.
Yeah, there'd be no writes happening to it, for example, which would then therefore mean that OS level disk caching could be incredibly more powerful in terms of the work that needs to be done, etc. So
to that point, it makes me kind of wonder if we should certainly try the simplest case of just have no other competing workload at all. Like we would be the only ones running a query on an otherwise completely idle cluster. But I also kind of wonder if that can't reproduce the problem to an acceptable degree. I'm wondering if maybe we could come up with a synthetic background workload, either read-only workload for dummy queries to run in the background, or ingestion of dummy documents, just to have something else competing for cycles. Does that make sense?
Yeah, there's obviously an infinite spectrum of how much work we put into that task, and like on the extreme end of it is like you just run a real GitLab server, a real GitLab instance that's actually doing realistic write workloads and realistic search workloads, and anything in between, it requires work to do, and it still has a real risk that it's not realistic enough to reproduce the problem, and so you don't actually know how far you move along that spectrum before you just go, oh, screw it, I should run a real GitLab server and run performance. I know we do have like these GitLab performance toolkit that can actually spin up a server with an Elasticsearch cluster and run these kinds of things against it. It runs daily, and it hasn't picked up any worsening performance over time. So if we actually use that performance toolkit, I'm not sure we'll be able to reproduce the same problem either. So anyway, those are the things I've been thinking for a while.
Yeah. That's a great call out. Yeah, that means that I kind of hate that they named it GPT. Because that says new partitioning table to me. Anyway, yes, if we, I kind of love that though as a background workload generator if we have to go that route. But yeah, we should start with the simplest stuff because it's very little additional work on top of building the cluster, which we want to do anyway.
So we're gonna put this in the back for now. Then we're not gonna focus.
Does that sound good to you? I think so.
Yeah, I think if anybody has any ideas in the meantime about things to explore, then please write them down. But if not, maybe don't invest a huge amount of time on it. And then we will get to provisioning an Elasticsearch cluster at some point. We'll do an experimental dry run with a real production size cluster restored from a snapshot. And at that point in time, we can see on that new cluster if there are any of these ways that we can reproduce these problems. If not, then have the discussion again about what to try next. But
yeah, I like that a lot, partly because it gives us a lot more visibility into what's going on under the hood than what Elastic Cloud is going to share with us. And second, it gives us kind of a nice concrete problem to explore on our new cluster with our new observability tools, which can potentially drive is the wrong word. It will clarify for us things that are and are not useful in terms of what we want to instrument, what we want to have ideally Prometheus collect for us in terms of metrics, and what kind of ad hoc tooling we'll have available now that we don't have running on Elastic Cloud. Yeah. Like I'm really itching to get a JConsole session open to see what MBeans are exposed and kind of share, if for anyone that hasn't seen it, how to do CPU profiling and memory profiling manually with Java's de facto tools.
Okay, so to clarify, the next actions then are with you two, but you're likely not to make progress the next week because you both have follow-up stuff from your on-call. But in general, the Terraform and Chef modules, figuring out how to run them, and then starting some level of experimentation with that, plus figuring out the Prometheus exporters that would go along with that. And that might be a couple of weeks away from you actually starting on it. Is that about right?
That sounds about right to me, and I'm hoping that in a couple of weeks we've got something to show for it. But yeah, I mean, pessimistically, yes.
Okay.
Does that sound right to you, Cindy?
Yeah, that sounds like a plan.
Okay.
All right. Well, thanks. Anything else before we wrap up?
I think there was another point added.
Oh, yeah. Oh, yeah. So running on Kubernetes, we did discuss this last time, and I think we just agreed on timeframes. We were going to not pursue Kubernetes for now. It's more important for us to get off of Elastic get Elastic off the vendor list than it is to figure out how to run it on Kubernetes.
Yeah, thanks.
Yeah, there's no like material blocker for doing so. It's just it's additional work that would be required in a couple of respects. So to shorten up the timeline, we're gonna go with VMs. Great question. I'm sure that some of the other SREs are going to ask the same question.
All right. Thanks, everybody. Sorry for going over time. Have a good afternoon. Bye-bye.
Later.